students, welcome back to Wisdom Academy YouTube channel. Today we are going to learn about magnetic effects of electric current. In the previous chapter you have learned about current, what is current and what is the heating effect of current. I hope that in the previous chapter itself you got clarity over what is heating effect of current, which was found by Joule, and Joule said that H is equal to I square RT, and how this formula was derived, and we did a lot of numericals based upon that. Now I am going to start the next chapter, which is magnetic effects of electric current. Like how Joule he found that current can produce heat, there was one person who found that movement of current even can produce magnetic field. So his name was Ørsted. So Ørsted was the first person to give some draft or give some explanation about how current can produce magnetic field. Before that, there was one Italian theorist. He also talked about this, but his theory was overlooked and it did not become a proper theory. But Ørsted's theory, when he did some experiments and he could prove that how the current produces magnetic field, it was accepted worldwide, and still we are reading it. So what did Ørsted do? He took a magnetic needle. I hope you know what is a magnetic needle. Magnetic needle is a needle which deflects only when there is a magnetic field around it. So it looks like this, and it will have north, south, like this is north, this will be south. North, south will be always blackened or darkened to identify as the north, south side, and this will be pivoted on any mount like this. So whenever there is a magnetic field, this will start deflecting. This magnetic needle or magnetic compass was used by people for navigation those days. So when they were navigating in the seas, they used to have this magnetic needle or magnetic compass, whatever you want to say. So what did Ørsted found? He took a basic circuit in which there was current passing. Let me assume like this, a very basic circuit. So since the positive terminal is here and negative is here, current will pass in this direction. I hope you can understand this. So when the current was passing in this direction, let me name the direction as, let this side be south north direction, right? So if this side I am taking as north and this side I am taking as south, then you will have direction of where will the east fall? So here I will have east and here will have west. So what will happen when there was a magnetic needle kept like this? North direction being here, what did Ørsted observe? He observed the moment he put this key on and the current started flowing inside the circuit, this needle started deflecting towards west side. So it started going in this direction. This was the first time when he could really observe that movement of current can produce magnetic field. Next, what he did in the series of experiments, this was the first case. So first what he did, he passed the current from south to north direction, and he found that magnetic needle's north was moving towards west. Then he changed the direction of current. So what he did, this polarity of battery he made negative and positive here. The moment he did that, direction of current will change. Now direction of current became from here to this side, and now what you observed was that deflection was in the opposite direction. That means south was coming in this way and north was going away in the east direction. So what he could conclude? He could conclude that as the direction of current is reversed, the direction of magnetic field is also reversed. He did not stop even here. He did a third trial in which in the first case, this needle was kept above the wire. Suppose this is the wire which is going, then the needle was kept above it. Second case, what he did, he kept the needle below this. So now when he kept the needle below this, again he was seeing that the direction of magnetic field is reversed. So what he did, first thing, he kept the direction of current from south towards north, and he saw that magnetic needle north direction was pointing towards west. Second, he changed the polarity of the cell and the current was flowing from north to south, and then he could find that the north of needle was deflected in the east direction. Then when he kept the needle below the wire, whatever happened in the above wire condition was reversed in below wire condition. And fourth, when he stopped passing current through this wire, magnetic needle again came back to its original position. There was no deflection in the needle. So all these series of experiment could give an idea to Ørsted that whenever there is a flow of current in a wire, it produces magnetic field. Later, even Ampere did some research on this and he gave something called a swimming rule, and this thing I wanted to give you as a homework, where you will go and you will find about what is Ampere's swimming rule, which will help you to find the direction of magnetic field. I will just give you one hint, that is called as snow. So snow was a term again coined by the people during that time, and what does this snow mean? Snow means that when the current is flowing from south to north and the needle is kept over the wire, then the needle will be deflected towards west. I will say once again, when the current is flowing from south to north and the needle is kept over the wire, then it gets deflected towards west. This can be remembered as snow. There is nothing like it is very compulsory to remember this, but it just gives you an idea to remember that whenever the current is flowing from south to north and the needle is kept over the wire, the needle gets deflected in the west direction. So obviously when the current will flow from north to south and the needle will be over that wire, then the needle will deflect towards east direction. So if you know this, you know all other things also. So I wanted to give this as a homework. So this is the introduction about this chapter, where you came to know that Ørsted was the one who first literally did experiment and proved that the current can produce magnetic field. So up to now you have understood that what is current? It is a flow of charge. When the charge is at rest, then that branch of physics is called as electrostatics. When the charge is at rest, it produces electric field around it. Was there any magnetic field when the charge was at rest? I don't think, no. When the charge is at rest, it produces only electric field. When the charge came in motion, then it becomes current, and when the current is flowing, it got both the effects, heating effect and magnetic effect. If you recall my first video of this series, I have talked about this, whether when you get electric field, when you get magnetic field, and when you get both the fields called as electromagnetic waves. If you want, you can go and see that video also. So with this, I would like to end this session. Being the introduction of this chapter, we have learned today about what experiment Ørsted did. In the coming video, you will learn about Biot-Savart law and its application. Thank you very much. Please like the video, share with your friends and subscribe our channel.